Okay, in the previous video of physics, we learned about work, power, and energy. So, in this video, we will be doing the numericals of this particular chapter, that is chapter number 2, work, energy, power. So, before we start with the chapter, we need to write the formulas of all the ones which are coming in this particular chapter. So, the formula, first one will be work, that is W is equals to F into S into cos theta, where we know very well W is the work. So W is work in joule, F is force in Newton, S is displacement in meters, and theta is the angle between force and displacement and line of displacement. Okay, that was the first one. That W is equals to Fs cos theta. The next which was there is we have over here as power. P is equals to W upon T, where P is the power in watt. Okay, or just say W. Then T is time in seconds. Okay, so that is power is equal to work upon time. We have another formula over here that power is equals to F into V. So where V is the velocity in meter per second. That is the next one. The fourth one is energy is equals to work done. So energy is equals to work done. We are just going to take it that way. We have another thing over here as work is equals to mgh. We just saw that. One sec. Yeah, that is where is it? 1gh. Okay, yeah. So that is W work done is equals to mgh, where m is the mass in kg. This g is the gravitational force, gravity, and h is the height. Okay, height of the object, that is h in meters. So W is equals to mgh. What else? We have got some conversions over here. Conversion is 1 HP is equals to 746 watt. That is one conversion. Another conversion which will be required could be the one is 1 watt hour is equals to 3600 joule. So that is another thing which will be required. Others we can just check it when we see a particular sum, we'll just write down those things also in between. I think this is good enough. Yeah, we can have one more over here, that is force is equals to m into g, that is mass into gravitational force. That is one more thing which is possible over here. So m into g, same mass into gravity, is force, which is also given as weight, or it can be given as weight. Okay, that is mg. Right, so these are the different formulas which you need over here. W is equal to Fs cos theta, P is equal to W upon T, P is equal to F into V. Energy is equal to work, and W is equal to mgh. 1 HP is equal to 746 watt. 1 kilowatt hour is equal to 3600 joule, and weight is equal to m into g. Okay, so we need this as the first thing in case of solving of numericals. Now we move further. Right, so we now move to the exercise, that is numericals of the first part of the chapter. So there are totally 16 of them. So I think we will divide into 2 videos. So let's see the first one. So first one, A body when acted upon by a force of 10 kgf gets displaced by 0.5 meters. Calculate the work done when the displacement is in the direction of the force at an angle 60 degrees with the force and normal to the force. So let's see one by one. The first thing is the data what is given to me is F is equals to 10 kgf. And they are given that G ka value is 10 Newton per kg. Therefore, we have F will be equal to 10 into 10 because it is M into G. This is nothing but mass into G is equals to 100 Newton. Okay, that's the first part. We have the displacement S is equals to 0.5 meters. According to the first one, W is equals to F into S because it is in the direction of the force. The direction of the force it will be equal to 100 into 0.5 is equals to 50 joule. This was W in direction of force. Okay, that is the first one. Second one is W at angle theta is equals to 60 degrees. So W is equals to Fs cos theta. So that is going to be 100 into 0.5 into cos of 60. Now cos 60 is given as 1 upon 2. So it will be 100. This is already 50. 50 into 1 upon 2. That will be 25 joule. So that will be 25 joule when it is in the direction at an angle of 60 degrees with the force. The third one is when theta is equals to 90 degrees because given that the normal to the force, that means normal to the force means this is normal to force, therefore theta is 90 degrees. So W is equals to Fs cos 90, so that will be 100 into 0.5 into cos 90 is 0, so hence the answer is 0 joule. So the work done will be 0 when it is going to be normal to the force. So this was the first question. We move on to question number 2. Okay, question 2 is this way. A boy of mass 50 kg climbs up the stairs and reaches the roof at a height of 8 meters in 5 seconds. So first thing is mass is equals to 40 kg. You are given the gravitational force G is equals to 10 meter per second square. The height is equals to 8 meters. The time is equals to 5 seconds. This is the data given to us. You first need to find out the force of gravity acting on the body. So first thing, force of gravity on body is equals to M into G is equals to 40 into 10 is equals to 400 Newton. The first answer is 400 Newton. Work done by him against the force. The second one is work done. W is equals to, here it will be equal to mgh. That is nothing but 40 into 10 into h is 8 meters. So it is 3200 joule. The third case. Third thing is power spent. What is power? Power is equals to work upon time. So that is going to be 3200 upon time is given as 5 seconds. So 5 seconds, that will give me 640 watt. Power is equals to 640 watt. Sum number 3. A man spends 6.4 kilojoule energy in displacing a body by 64 meters in the direction in which he applies force in 2.5 seconds. So we have got the first one is man spends energy. So energy E is equals to 6.4 kilojoule is equals to 6400 joule. Therefore, work is equals to energy is equals to 6400 joule. The next thing they are given me that displacement S is equals to 64 meters, time is equals to 2.5 seconds. You need to calculate the force first. So we know that W is equals to F into S because in the direction of the force, so you don't need cos theta. So W is equals to 6400 is equals to F into 64. Therefore, F will be equal to 6400 upon 64 is equals to 100 Newton. So F will be 100 Newton. That's the first part. Second part is the power spent in HP. So the second part is power is equals to work upon time. The work was 6400 upon time was 2.5 seconds. So we have over here, if you divide this, 25 2s and then 140. 140 will be 5 are 125 and then it will be 15. So 156. So this much. So that will give me as 2560. Okay. So 2560 joule. Therefore, power in HP is equals to 2560 upon 746. That will give me something like 3.43. So 3.43 HP. Got it? This was the sum number 3. Clear? Right. We move on to sum number 4. Sum number 4. A weightlifter lifted a load of 200 kgf to a height of 2.5 meters in 5 seconds. So we have got the first thing as mass is equals to 200 kgf. G is equals to 10 Newton per kg. Therefore, F is equals to, okay, let's not write that first. We'll write over here height over here as 2.5 meters. Time T is equals to 5 seconds. You need to calculate the work done. So work W is equals to mgh. It's 200 into 10 into 2.5 meters. So it's 5 into the 5000 joule. Work done will be 5000 joule. That's the first answer. Now next thing was the power. So power is equals to work upon time, that is 5000 upon 5, that is 1000 watt. Okay, that is the power. So these are the two answers. First answer, second answer. Very easy, clear. Main thing, you need to learn the formulas properly. If you learn the formulas, then these are all very easy sums. It is just application of the formula. So that's sum number 4. We move on to sum number 5. Okay, sum number 5. A man raises a load of 750 Newton through a height of 16 meters in 5 seconds. So he raises a load. So it is given that force is equals to 750 Newton with a distance S is equals to 16 meters in a time equal to 5 seconds. Calculate the energy spent. So work is equals to F into S is equals to 750 into 16. So 75 into 16, 16, 6 5 30, 42, 43, 45, 0, 5, 7, 0, 0 and 12. So that will be 12000 joule of the and work done. Now work is equals to energy. Therefore, energy spent is equals to 12000. Okay, no confusions. Joule. Okay, this is the first part. The power of the machine. So power of the machine, power is equals to W upon T. that is 12000 upon time was 5, so that gives me as 2 and then 400. It's 2400 watt. That's the power. Clear about this? We move on to the next sum, that is sum number 6. Question number 6. An electric heater of power 3 kilowatt is used for 10 hours. How much energy does it consume? Express your answer in kilowatt hour and joule, both. So first one is, we get over here, the first one is power is equals to 3 kW, time is equals to 10 hours, therefore energy consumed, now because it is energy consumed by electric current, so it will be consumed in kWh will be equal to P into T, which is nothing but 3 into 10 is equal to 30 kWh. See, it is just kW and this h. kWh will be just multiplication of the two. That's the first part. So that's the first part over here. The second part over here, they want this thing in joule. So we know here that 1 kilowatt hour is 3.6 into 10 raised to 6 joule. Okay. If you see the earlier one, we written that 1 watt hour is 3600. तो 3600 में और 3 0 ऐड करेंगे तो 3.6 into 10 raised to 6 हो जाएगा. So that will be 3.6 into 10 raised to 6. So automatically 30 kWh will be equal to how much? So 30 into 3.6 into 10 raised to 6. So that will give me as 6 3s are 18 and 6 3s are 9 10. So 10 108 is the multiplication of this thing is 108. So accordingly it will be 1.08 into 10 raised to 8. That will be in joule. Okay, 1.08 into 10 raised to 8 joule. Got it? Simple. We move on next to the sum number 7. A water pump raises 50 liters of water through a height of 25 meters in 5 seconds. Calculate the power of the pump. They're given that the density and the mass G of the thing. So we have volume of water V is equals to 50 liters. We have the height to be as 25 meters. Time is equals to 5 seconds. G is equals to 10 Newton per kg. And the next they are given is density is equals to 1000 kg per meter cube. So I know over here that I need to find out the mass, only then I can use mgh. So mass, I know that density is equals to mass upon volume. So mass is equals to density into volume is equals to 1000 into liters hai ye. This is volume is in liters. So the liters, if I convert it into, I'll have to convert the liters first into meter cube. So that is the main thing, that it will be equal to 50. So 50 liters will be equal to 50 upon 1000 meter cube. That's the thing. So it will be 50 upon 1000. So this 1000 gets cancelled, is equal to 50 kgf. This also shows one more thing, very important thing in case of water. When the density is given to you as 1 or 1000 over here, 1 gram per centimeter cube or 1000 kg per meter cube, that in case of water, whatever may be the value of liters, the same is the value in kg. Okay, 50 liters is 50 kg, 100 liters would be 100 kg, 1 liter is 1 kg. Okay, You can remember this thing, but otherwise you can use this form. So mass is this much, so m is equals to this much. So therefore, I have over here that what is the question? They asked us the power. So we need to know the power over here. So power is equals to W upon T, which is nothing but mgh upon T. So the m is 50, g is 10, and h is 25. Upon time is 5 seconds. So 5 5s are 25. So this will be 2500 watt. Okay. So that power over here will be equal to 2500, that is 2500 watt will be the power in case of sum number 7. We move on to sum number 8 now. Question number 8. A pump is used to lift 500 kg of water from a depth of 80 meters in 10 seconds. So we have got over here that the mass is equals to 500 kg to a depth of h is equals to 80 meters, and they have given me the time is equals to 10 seconds. You need to find out the work done, and the g is given to you as 10 meter per second square. So we have got, first of all, the first thing is A is work. W is equals to mgh is equals to 500 into 10 into 80. 5 8s are 40, and then 1 2 3 4 0 1 2 3 4 zeros. That is this many joule. So it is, we can write it as 10 4 into 10 is to 5 joule, but you can keep it like this as it is also. The second part of this is power at which the pump works. So power is equals to work upon time, that is 4 lakh upon time is 10 seconds. So that is going to be 40,000 watt. Okay, 40,000 watt will be the power. Now the power rating of the pump, if the efficiency is 40%. So they are given over here efficiency is 40%, but that means, see, the efficiency in the formula is equals to, efficiency is equals to useful power upon input power input. Okay, we can also say output upon input. Now you see that this is what we got. What we got is the output. Okay, what we got is the useful power, that is the power what we used. Okay, so we want the efficiency. If this was the thing, we want the efficiency is going to be as 40%. So it is over here 40% is equals to 40,000 upon input power. Okay, so here you see this 40% is nothing but 40 upon 100 is equals to 40,000 upon input. Hence what happens? So we see over here input will be equal to input power is equals to, so this goes here and this will come down and this will go up. So it will be 40,000 into 100 upon 40. So this 0 goes here, 4 goes here. So this is 10,000. So this is going to be 1, 2, 4, 5. 5 watt. So you can see over here this was 40,000, but this is 100,000, 1 lakh, or we can say is equals to 100 kW. So power input. So what question was, find the power rating. So the power rating is 100 kW. So this was question number 8. We said the next one, question number 9. Okay, question number 9 is An ox can apply a maximum force of 1000 Newton. It is taking part in a cart race, and is able to pull the cart at a constant speed of 30 meters per second. So what you are going to get is, we get here that the force is equal to 1000 Newton and the velocity it is traveling is 30 meters per second. We need to find out, calculate the power. So you got over here, while making it specified, calculate the power developed by the ox. So we have the formula, power is equal to F into V. So that gives me 1000 into 30 is equal to 30,000 watt. Okay, that gives me equal to 30 kilowatt. That's the power generated by the ox on the cart. Let's see the next one. Sum number 10. The power of a motor is 40. So power is equal to 40 kW is equal to 40,000 W. At what speed can the motor raise a load of 2000 Newton? So force is equal to 2000 Newton. So we have the power is equal to force into velocity. We need to find out the velocity. So 40,000 is equal to 20,000 into V. So V will be equal to 40,000 upon 20,000 is equal to 2 meters per second. So the velocity at which it can be, the motor can raise the load will be 2 meters per second. We will stop here for this video. We'll continue in the next video from 11th Psalm.